Question number 9 is a very regular trigonometric identity question. So sum of the angles are given. We have to obtain an expression for sine 2 theta in terms of cos squared theta. So we can write left hand side or simply cos 2 theta as theta plus theta, and we know cos A plus B is cos A cos B, so this would be cos theta minus sine theta sine theta. So that would be cos squared theta minus sine squared theta. Now we leave this, but we convert everything else to cos squared theta. So that means from the fundamental identity, sine squared theta is 1 minus cos squared theta, and that turns out to be cos squared theta minus 1 plus cos squared theta, that is 2 cos squared theta minus 1. So shown, that's shown. We might not have to write this left hand side because we're not proving anything, we're just obtaining an expression. So question number B, express sine 2 theta. So we can write here sine theta plus theta. So we know sine A plus B is sine A cos B, so this is going to be sine theta cos theta plus cos A sine B, so cos theta sine theta. Since it's the same thing, we can write 2 sine theta cos theta. So we found two expressions. So question number C is also a common question. So cos 2 theta. So this one we have to show. So we have to write left hand side. So left hand side, it's a very important part of the presentation here. So remember that. So cos 3 theta is cos 2 theta plus theta. So using the rule of cos A plus B is cos minus sine. Sine, this would be cos 2 theta minus sine 2 theta sine theta. So let's break down what we have done previously. So this is going to be 2 cos squared theta minus 1, and this is going to be cos theta minus sine 2 theta is going to be 2 sine theta cos theta, and this is going to be sine theta. The next one, so let's multiply cos theta into cos squared theta. So this would be 2 cos cubed theta minus cos theta into 1 is cos theta, minus we have sine theta into sine theta. So this is going to be 2 sine squared theta, and we have cos theta here. So we are almost done. The only thing is that the answer has to have only cos theta. So let's convert the sine squared theta. So this would be cos cubed theta minus cos theta minus 2 cos theta. So let me write this sine squared theta over here, 1 minus cos squared theta. So it turns out to be 2 cos cubed theta minus cos theta minus 2 cos theta into 1 is 2 cos theta, minus into minus is plus, 2 cos cubed theta. So 2 cos cubed theta plus 2 cos cubed theta is 4 cos cubed theta, and minus cos theta minus 2 cos theta is minus 3 cos theta. So we have proved this, therefore left hand side is identical to right hand side, proved. The next question, question number D. So question number D says solve this equation. So question number D, so let's solve this equation. We have 9 cos theta minus 12 cos cubed theta equals to 2. Obviously we cannot solve this equation, so we have to use the previous sum somehow. So the previous sum we proved 4 cos cubed theta minus 3 cos theta. Instead of this whole thing we can write cos 3 theta. So we're going to use that, otherwise we cannot solve this. So what we can do is we can take 3 common here. It becomes 3 cos theta minus 4 cos cubed theta equals to 2. Then we can send the 3 to the other side. It becomes 3 cos theta minus 4 cos cubed theta equals to 2 by 3. Now if we multiply both sides by minus, we can get this 4 cos cubed theta minus 3 cos theta. So then we get 4 cos cubed theta minus 3 cos theta equals to minus 2 by 3. So now we have multiplied both sides by minus. Therefore, instead of this, we can write what we just shown before is cos 3 theta equals to minus 2 by 3. So now we have this. Now we have to solve this. Remember here that we have the answer as 0 to pi. 0 to pi means 180 degree. Now if this is multiple angle, 3 theta means multiple angle rule. So that means the answer should be 6 angles. So if the range is from 0 to 180 degree, that means half of that, because from 0 to 360 degree, there should be, for multiple angle, it doubles. So there should be 6 angles. So if you take half the range 0 to 180 degree, that means instead of 6 angles we should have 3 angles. That is good enough. So we are expecting 3 angles. At the same time, remember, it has to be in decimal places, in radians. That means we have to use the calculator and convert the calculator to radian mode. So let's start doing the calculation over here. The first thing that we do is the quadrant. So cos theta is negative, so that is going to be the sine quadrant of the second quadrant and the tan quadrant of the third quadrant. So now we have to find the basic angle. So therefore this multiple angle 3 theta is our basic angle now. So this is going to be cos inverse. In the basic angle we don't take the negative sign, we take just the positive sign. So 2 by 3. So now bring out our calculator. It's in degree mode, so for this sum, remember, we have to convert it to radian mode. So radian mode means this 2 rad mode. Okay, so cos inverse of 2 by 3, that is going to be 0.8411. 0.8411. Okay, so this is 0.8411, basic angle 0.8411. Remember, this is multiple angles, we cannot break this down. So the first one is going to be 3 theta equals to, second quadrant means 180 degree minus, so this is the radian mode, so this would be pi minus 0.8411. So this would be, so pi minus 0.8411 turns out to be 2.300. So I'll just write 2.3. And after that, so we get 3 theta equals to, now we have the third quadrant over here. So that is 180 degree plus. So pi plus 0.8411. So that would be pi plus 0.8411. That would be 3.9827. So 3.9827. Let me check. 3.9827. Okay. So remember, if the range was from 0 to 360 degree, we should have 6 angles. But since the range is from 0 to 180 degree, I'm saying in terms of degrees because it's easier for me to think in that way. Of course, it's in radian. So it is 0 to 180 degrees. So it means we need half of 6 angles, meaning 3 angles. We found already 2. So we need 1 more. So what we can do, we can just do 1 revolution for this. So we can add 360 degree to one of the angles. And we can write, so 3 theta equals to the first angle 2.3 plus 360 degree or complete revolution. So that would be 2 pi. So 2.3 plus 2 pi. So 2 pi plus 2.3. That is going to be 8.5832. 8.583. Okay, 8.583. Now the answers. So theta. When we write down the answers, we don't need the multiple angles anymore. We just need the theta as the answer. So the first one is going to be 2.3 divided by 3. 2.3 divided by 3. That should be 0.7. How many decimal places do we need for the answers? I think we need significant figures, or 3 significant figures. Okay. So the first one is supposed to be 0.767. So 0.767. So 0.767. Next one we need 3.9827 divided by 3. So 3.9827 divided by 3, that gives theta. So that would be 1.33. 1.33. So that is 3 significant figure. 1.33. Now the concept of significant figure is very important everywhere. Decimal place is significant figure, so the concept of math bay is important. So 8.583. So 8.583 divided by 3, and that should be 2.86. So 2.86. So 2.86. So that's that. That's the answer for the multiple angle question. We have one more here. We have to integrate this. So obviously we cannot integrate cos cubed. Let me remind you, the derivative of cos x is minus sin x. So the integral is the opposite of differentiation. So the integral of sin x is minus cos x. So let me write this down here. That okay. So the derivative of cos ax is minus sin ax, and of course we have the chain rule all the time. So the integral is going to be the opposite. You just take the answer and you integrate this and you'll get this one. So this time the minus will go to the other side. So minus cos ax, and the chain rule would be divided because everything is opposite now. Even the multiplication is divided, and plus c. So that what happens. So you have to remember that. So how can we do this? First of all, cos cube 3. So we have to use the identity of the previous sum. So previously we wrote write this down. Question number E. We know cos 3 theta is identical to 4 cos cube theta minus 3 cos theta. So we need an expression for cos cube theta. So this should be cos 3 theta plus 3 cos theta divided by 4 is cos cube theta. Remember, we can only integrate angles, not powers of cos. So we can only integrate cos of some angle or that. We cannot integrate anything else. So we can now write this down as this. So therefore, integration of 0 to pi by 2 is the limit. We write here 3, and instead of cos cube 3 we write cos 3 theta plus 3 cos theta divided by 4, and then we have plus 2 sin theta. So this is it, d theta. We have to integrate this. Now we can write this down as integration of 0 থেকে pi by 2. So we have 3 by 4 cos 3 theta plus, if you multiply this, 3 3 is a 9 by 4 cos theta plus 2 sin theta d theta. Okay, so I mentioned the derivative of cos theta. Now let me tell you about the integration. So if I were to differentiate sin theta, sin x, so it would be cos ax, and the chain rule would be d by dx of ax. So the opposite automatically becomes this one. So integration of cos theta is simply going to be sin theta. That's it. And remember, the chain rule is going to be the opposite too. So divided by d by dx of x plus c. So this is going to be 3 by 4 cos 3 theta integral is going to be sin 3 theta divided by this derivative. It is going to be 3 plus 9 by 4 cos theta is going to be sin theta divided by this angle derivative is going to be 1 plus 2 sin theta. So as we know, the integral of sin theta is going to be minus by the fundamental rule of calculus. So this is going to be minus cos theta, and the angle theta derivative is 1, and we don't have to write plus c because we have a limit. So 0 থেকে pi by 2. So let's simplify this before we can put the limit. So this 3 and 3 cancels. It becomes 1 by 4 sin 3 theta plus 9 by 4 sin theta minus 2 cos theta, and it's going to be 0 to pi by 2. So let me put down the values. So it would be 1 by 4 sin 3 pi by 2 plus 9 by 4 sin pi by 2 minus 2 cos pi by 2. So that's the first limit put. Minus 0, sin 0 is 0, plus sin 0 is again 0, minus 2, cos 0 is 1. Okay. So now 1 by 4, now sin 3 pi by 2. So If you think in terms of, let me bring on the calculator. So this is in the radian mode, so I can write sine 3 pi by 2 turns out to be minus 1. So this is minus 1 plus 9 by 4. Sine 90 degree is 1 minus cos 90 degree is 0. And this is minus 2. So what we have here is that 9 by 4 minus 1 by 4. So 9 by 4 minus 1 by 4. And we get 2, and this is going to be minus minus plus, and this turns out to be 4. So remember, we can only integrate sine theta or cos theta. If there is a power, you have to use the previous sum identity.